Hello, testing, testing, 1, 2, 3. Can you all hear me?
Yes, doctor.
Okay, all right. Okay, Kiang, shall we start now?
Yes, sure.
Okay, all right. Okay, hi, what's up? Assalamualaikum warahmatullahi ta'ala wabarakatuh, and very good morning. Welcome to our much awaited webinar on electric vehicles, the Malaysian future in your hands. So we have a theme together with webinar, which is to create the world of clean energy. Okay, today, 29th April 2021. Before we start, I would really like to observe, because this is actually a month of Holy Ramadan, where all Muslims are basically all over the world are fasting. So if you don't mind, allow me to recite a verse in the Al-Quran, our holy book, and a hadith or a saying of our Prophet, Rasulullah Sallallahu Alaihi Wasallam, about fasting in this holy month of Ramadan. Okay, if you don't really mind. Laqad qala Allah tabarakallahu ta'ala fil Qur'anil Majid, ba'da'uz billahi minasyaitonir rajim. Ya ayyuhallazina amanu kutiba alaikumusiyam kama kutiba alal ladzina min qablikum la'allakum tattaqun. O believers, fasting is enjoined or instructed upon you as it was enjoined or instructed upon those before you, so that you become God-fearing. And waqala Nabi sallallahu alaihi wasallam, man shoma Ramadan imanan wa ihtisaban ghufira lahu ma taqaddama min zambi. Whoever fasted the month of Ramadan out of sincerity, sincere faith and belief, and hoping for a reward from Allah subhanahu wa ta'ala, then Allah, all his past sins will be forgiven by Allah subhanahu wa ta'ala. Kama qala salatu wassalam, sadaqallahu al-azim wa sadaqa rasulun nabiyul karim wa nahnu ala zalika minasyakirin. Walhamdulillahi rabbil alamin. Thank you guys for your kind patience and attention to the verses that I've just cited. Okay, this webinar is held in conjunction with the IEEE PES Day 2021 with this special theme called Clean Energy Revolution. It is this particular webinar is jointly organized by the IEEE Power Energy Society Malaysia Chapter, IEEE Malaysia Section, of course, the head. And then we have IEEE UPM, PES student branch, and then UPM itself, our Universiti Putra Malaysia. And we also have IEEE Women in Engineering. And last but not least, also organized by our very own in UPM, Advanced Lightning Power and Energy Research. The program director of this webinar is Mr. Lim Ki Yang of UPM. I'm your moderator and a host for this webinar. I'm basically attached with ALPER, Advanced Lightning Power Energy Research UPM, and also an advisor for the IEEE PES, Power Energy Society UPM student branch. We are really so much privileged and honored to be here, as we have with us the honorable and distinguished speakers from mixed background of academics, government agency, as well as in industry on particularly on electric vehicles. So let's take this opportunity to thank, first of all, our program director, Mr. Ki Yang, for making this possible to engage these respected guests, speakers. And our sincere appreciation, of course, to the speakers themselves for taking their time off, especially during this holy break of Nuzul Quran. It's actually a holiday today. So we really appreciate your time. And of course, last but not least, our respected audiences, right, who have sacrificed your time, your effort to be with us. Right? Who are our speakers? Okay, those our speakers, our distinguished speakers are, we have with us our Honorable Professor Ishak bin Aris. Okay, he's a professor in the Faculty of Engineering, Universiti Putra Malaysia. UPM is a Malaysian Public University. And then we have professional technologist P.S. Bakri alias. He's the Senior General Manager of Malaysia Automotive, Robotics and IoT Institute. We call it MARI, M-A-R-I-I, which is a Malaysian government agency under the purview of Ministry of International Trade and Industry Malaysia, or MITI. And we have our next speaker, Engineer I.R. Lee Yuan Hao. He's the founder and director of EV Connection Sendirian Berhad. So this is actually a private company. So welcome aboard our distinguished speakers. Okay. The way that we are running the program afterward will be as such. Right immediately after my introduction, we'll have our speaker, Professor Ishak, to be sharing his knowledge for 20 minutes. 20 minutes. And then right immediately after that, we have another 20 minutes. 20 minutes by technologist Bakri alias. And finally, we have another 20 minutes by engineer Lee Yuan Hao. And then the question and answer session will only be allowed to be posted immediately after the final speaker. So this, depending on our time, the availability of our time, we'll take as many questions as possible. All right. We can, you can ask either through, direct questioning using this platform, or you can also write or type text over the chat field available in this platform. Okay, without further ado, let's get the ball rolling. So our first speaker, all right, our Honorable Professor Ishak bin Aris. Let me just give him a bit of introduction of himself. He's a professor from Department of Electrical Electronics, Faculty of Engineering, having many years of experience. He's basically my mentor. He's my supervisor for my master's and PhD. He's involved in the various fields, including electric vehicles, automotive, electrical electronic system. He is our past president and advisor of the Society of Automotive Engineers, SAE International Malaysia. He's also, of course, my colleague in ALPER, Advanced Lightning Power Energy Research, UPM. Okay, the topics or areas that Prof. Ishak will be sharing will be about basically in the perspective of academics, especially on the recent rise in popularity of EV, and of course, basic exposure on EV. So without any delay, I would pass the mic over to Prof. Ishak. Over to you, Prof. You may begin now.
All right, thank you very much. First of all, I'd like to say thank you very much to the organizer, Mr. Lim, for inviting me to talk to the audience today, and also my colleague, Prof. Luffy, for very kind introduction, and also my friend, Mr. Bakri from Mari, and also my new friend here, Mr. Lee. It's our first time meeting online. Meeting online. So I'm like very much and delighted to be here today and to share some of my knowledge to the audience. So now I'm sharing my presentation, if I may. Okay. Can you see my screen now?
No, Professor.
Can you see my screen?
Not yet, Prof.
Not yet.
Not yet. It should be coming any moment.
Is it? Okay. Is it okay? Yes. No.
Not yet.
Not yet.
Yes.
Check. Okay, no, I won't. I'm presuming this I already logged in. Okay.
Yeah, it's coming, Prof.
Coming. All right. All right.
Yes.
Good. Alhamdulillah. Alhamdulillah.
Okay.
Okay. All right. So we can see my screen, right?
Yes, clear.
Okay. Alhamdulillah. Alhamdulillah. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning to all my friend, my colleague, and my new friend. So I'm very thankful for the organizer for inviting me to give a talk on this what I call it this topic. So I just take the title of the seminar itself. So the EV, the Malaysian future in your hands. Yeah? So it's a very big topic because it involves everything from the R&D, then from the marketing strategy, and up to the policy makers, which is the government. So but for today presentation, we have all the component. We have representative from industry. We also have a representative from the government agency, yeah, and also I'm representing from the what I call it, from the university. So I will talk more toward the R&D, what we have in order to support the what I call it the EV development in Malaysia. Yeah? Okay, that's about all right. Okay. This is my table of contents. So first, I'm going to give you the introduction, how we going to move toward the topic which we're going to discuss. Then I focus on my part will be focusing on the EV R&D. Then after that, give the conclusion. Then the second part will be maybe what I call it, Mr. Bakri. He will talk on the policy, or perhaps maybe NEP, National Automotive Policy, particularly in EVs. What type of policy supporting this particular initiative. Then after that, we have our friend from the industry, Mr. Lee. Then he's going to talk in terms of what I call it industry point of view. So let me share my thing. This is for the international audience. This is KLCT Center during night time. This is the Twin Towers. So what I call it? Our University UPM is about 40 minutes if you drive a car without jam. So that is the distance between what I call it our university and the KLCT Center. Then of course this is some snapshot from what I call it from UPM. So this is the campus of the Faculty of Engineering. Yeah, so the Faculty of Engineering complex just next to the highway. So this is our offices. This is also some research center are here. This is what I call it some classes and some laboratories. Okay. So this is the current status of our university based on world QS world ranking. So we are now 132, position of 132 worldwide. So, and for new university, because what I call it UPM is young university. Just now it was overall, regardless whether old or new university. That in terms of a new university ranking, we are top 10 based on this QS world ranking. Yeah. So to start with, let me see the current scenario now. So now everybody talking about the smart city, what are the things. So this is some of the opportunities available currently. We call it based on the demand. Based on the demand. So because people from rural area immigrating to the cities to find job, that kind of things. So a lot of initiative has been what you call it, developed in order to suit of this requirement. Then currently now the world population is about 8 billion. So majority, what you call it, very big opportunity for to grab all this type of what I call it, research area in this particular domain. So transportation is one of them. Transportation among these application, transportation is one of them. So based on this, of course, currently we use ICE, internal combustion engine, but the issue of internal combustion engine is that it has a problem of pollution, and at the same time we also facing depletion of fossil fuel. So that forced the researcher to find an alternative way to provide to this transportation industry. So based on this, people are proposing EV is one of the solution to address issue of pollution, at the same time also on the energy side. Of course, this thing is not come in what you call this in easy ways, but of course a lot of obstacle, and of course a lot of opportunity in terms of research and also businesses. Okay, so against why we need EVs in this community. So as I already mentioned just now, we need to address the issue of greenhouse effect, which is the environmental. So we need to keep our environmental clean, because the EV produce zero emission. Of course, people say that it produces the zero emission, but to charge that thing, you need a power station to what I call it, to deliver the electricity to the charger, and the power station also using fossil fuel. Of course, there are some combustion, but at that level, normally is what I call it, centralized, so easy to control that type of pollution, because for the vehicle is moving around, very difficult. So this is one of the solution. And of course, this is the roadmap developed together with MARI last time. Now MARI last time it was known as MAI, Academy Malaysia. This is the effort of collaboration between Academy Malaysia, MAI, and of course from the industry and also university. We come up with this roadmap for the what I call it, automotive industry, in terms of short term, medium term, and long term. You can see various type of technology using this one in Malaysia. So we are focusing. If you look at this timetable, that if you look under this is ICE, it's going to be there for quite some time, but it's going to be replaced by this the EV and also hybrid along that line. Then maybe toward the end, probably we go for full autonomous vehicle. So this is some of the what I call it, forecasting, at least in Indonesia. Then the motivation, the further motivation, MARI under Malaysian Automotive Technology Roadmap, also they are providing this what I call it, initiative in terms of sustainable mobility. So in terms of you can see competitiveness, green mobility, environmental safety, green vehicle technology, and so on. So in terms of policy, yes, what I call it, the government, they are putting up effort in order to support this initiative, but of course need some further improvement from time to time, in order to really what I call it, encourage the players, especially the industries, to take up this offer. All right, so this is taken from NAP 2020 based on total production unit. total production unit. You could see here, this is the total sale for for the vehicle, and this is for total global green vehicle sale. So you can see there. So this is for if you look this, the black color is global total green vehicle sales, and this color is the blue color is global total vehicle unit. Yeah. So you can see that the trend is moving up and up. Yeah? Moving up and up from 1.9 now it become 4.1 million in 2008. Now the latest figure maybe it go beyond than this number. So this is in terms of ASEAN vehicle sale, 12% growth from 2014 to 2018. Okay. Then this is another what I call it taken from National Automotive Policy, the development in the global automotive industry, all the incentive direction and also technology trend. Okay. Right. So for this, what I call it, the effort of encouraging the EV in Malaysia, there are few things need to be considered. There are many factors need to be considered. This is one of them. What I call it, pricing. Yeah. Make sure that the vehicle is affordable. Otherwise, if too expensive, the consumer cannot buy the things. Then of course, consumer award also after sales service. Are they good enough or are they expensive? So this is another thing we need to consider. And also in terms of customer experience, so whether they like this technology or not. And of course, on top of that, government need to come up with what I call it, good incentive and regulation regarding this EV. And of course, the EV technology itself and the infrastructure available in today. If you can see, like for today, if you go into the supermarket, whatever, the infrastructure is still lagging behind. So because in terms of sale, maybe not much yet. In terms of public reception on this technology, maybe it's not very good yet. So, but of course, with the right strategy, this thing can be changed. Can be changed for sure. What I call it, we can address all this issue. Once we address this issue, then perhaps the consumer will come and take up the things. On top of maybe the strategy we can implement it before go to general public consumer. We could also go into type of like what I call this, companies, maybe based on that they can use this EV technology to start with. Then after that, maybe the sale can be extended to normal public once the public or consumers, I call it, pleased with the technology, with the right pricing. I think this thing can be further what I call it, further developed. Okay, then of course for university in terms of we are supporting by providing some technology. Of course, if you look at now, everybody, all the big players, they are having their own technology. Everybody from US, from Europe, from Japan, from China. So there are many technologies on the EV. They're already there, from the vehicle itself and also on the charging facilities. Yeah? So in Malaysia also, we have some initiative. Perhaps there are some universities also looking into this to provide some alternative, maybe perhaps for the local players, so that when we develop the technology, perhaps that we could initiate something so that at least in future the Malaysian also can produce this EV technology rather than become user of the EV technology. So by having that, if let's say we are producing good quality EVs, then maybe perhaps that can become our additional income to our nation. So of course, we are moving toward that. Then we see how we can go. So for example, like this is some of the initiative. So we also developing this BCI, brain computer interface, that can be used in the EV, especially for what I call it for handicapped people, you know, and maybe for not just handicapped but older drivers. Maybe that because the nation become older and older, so the need for transportation is always there. So this is another thing. Maybe perhaps we Malaysian can participate in this thing, because not everybody provide this. Of course, the EV technology is there, but some additional or some system still what I call it need to be further developed. So we take this type of opportunity. So on our part, we are providing this. Of course, the BCI can be used for transportation and also for medical application as well. So this is our initiative where I play a video. Hopefully that it can be seen. Can you see the video? Can you see the video?
Yes.
Yes, Prof.
Okay. So this is the wireless EEG, which is used to develop this BCI. So this BCI can further be used in the EV, especially on the can be further developed for what I call it, can be further developed for active safety feature in the vehicle. For example, anti-drowsing, maybe perhaps semi-autonomous. So these are the thing we can be added into the vehicle system. So this is the system under test. And also we also look into this electric bus itself. We have projects on the electric bus where we involve some of our students involved with the what I call it this technology as well. So this feature also can be implemented, the BCI on the driver side. So this is some of the EV involved in the project. Some of the drawing where we have the in-wheel motor implemented in the powertrains. Then this is some of the what I call it some of my postdoc and also PhD student working on this project. Then also, of course, we also in terms of autonomous, we came up with some strategy can be implemented in the vehicle itself, starting from the when we develop the simulation, we develop the strategy. Okay, so you can see this is the moving, then this is the dynamic what I call it obstacle. So the vehicle will try to try to avoid the dynamic vehicle. So that is part of some of the strategy need in the autonomous vehicle. So on top of that, we also look into the what I call it this implemented it in a small scale first. Okay. So after we simulated the thing, then we implemented in this small scale. Okay. Right. So hopefully that this technology can be further implemented in the bigger or what I call it in bigger vehicles, so that we can achieve the autonomous feature in the vehicle. This is for the future. Maybe there's no driver in the future. And our team also involved with a vehicle communication system. Is very important for the implementation of the autonomous and also the EV, because based on this one, we are targeting that the vehicle can be communicated between vehicle to vehicle, vehicle to center, vehicle to infra, that kind of things, to provide the support of this what I call it this initiative. Okay, so we are developing the technology which are using improving the communication system inside the vehicle using optics and also combined with the wireless system. So based on that, we can achieve the transmission rate of 10 gigabit per second, which allow us to control the videos audios plus standard data. Yeah, so hopefully that so this is some of the initiative. Hopefully you can see this. So now I'm playing the video here. So this is the instrumentation panel. So this is using optics inside the vehicle, so to achieve the highest speed, and also the wireless between vehicle to vehicle as well. Okay, so this is can you see this video?
Yes, Prof.
Okay. All right. Yeah. So all okay, that is another things, right? This is in future they go for 5G for this particular thing, regardless of what type of vehicle. It can be EV, it can be autonomous vehicle, it can also be ICE. Yeah. They are moving toward a 5G communication now, right? So just skip on this thing. And also we have effort to in terms of type of energy sources used by the EVs. On top of the battery, we also look into multiple sources of energy. This one using a fuel cell, supercap plus the battery. We combine all of this strategy. So at the lab level, we implemented this technology to the robotic system. So due to some budgeting problem, so we try our ideas first on a small scale. Once we have that thing done, then we can approach a bigger sponsor to upgrade the prototype. So, okay. So this is the. Oh, I don't know. Let's see. Okay, you can see. So this is the what I call it. This is the supercap, fuel cell, and also from the battery part of it. So we are combining all of these things together. Yeah? Okay. And we also have a technology. We also developed for the infra as well. For this one, universal EV charger. So which normally that can address the issue of different what I call it protocol of the EV, because like from European, maybe they have different standard for charging. China different standard, and also what I call it Japan may be different. So our charger, regardless of what type of vehicle, we can address that particular issue. Yeah. So this we also what I call it conducting this thing as well. So then we also use the renewable energy for charging what I call it charging the vehicle. So but here we use ocean energy. We harvest electricity from the ocean. Then we can also use for EV charging and also non-EV charging as well. Yeah. So this is our effort as well. Can we see this? So this is the linear generator. This is the three-phase output coming out from the linear generator. So the linear generator is operating at the speed of the wave. Okay, so and this is the motor to simulate the speed of the wave, the height of the wave. This is the linear generator. And for this is part of our work as well. Some what I call it strategy to use for the charging of the vehicle. And on top of that, we also provide the wireless charging for this EV application. Okay, on top of that, we also provide the automatic charging for this one. So just now it was manually, now it's fully automated. So now we have a project to upscale this project for a bigger prototype EV. Okay, then this is what I call it based on coilless charging. Yeah, coilless charging. There is no a coil. Before that, we use a coil to do that wireless charging. So this is the technology which have coilless power transfer. And we also have project on the EV powertrains. Yeah, so this is some of the things. So in the EV powertrain, we develop the converter system, the battery pack. This is the battery pack to drive the electric motor. That is the motor. This is the battery pack design. Okay, and we also develop what I call it this a new electric machine for the EV. This is using a linear motor. So this could replace the current electric machine. Okay. Okay, on top of that, of course, on top of a standard fuel, people now also looking into the hydrogen fuel cell, which you saw just now, where we combine all the three types together. Of course, on top of the vehicle, we also looking into security system of the what I call it, system of the EV, this electric vehicle, this electric motor. This is we keep on improving the technology for the electric motor. Okay, I think enough. Right. Okay, I think that one same thing. Okay, so I'd like to conclude the presentation. Hopefully, with this new technology that we have developed, that can further reduce the cost of the what I call it the cost of the what I call vehicle, and maybe perhaps Malaysian in future can provide or become technology producer for the EV. Okay, so with that, I think I give back the things to the chairman. Let me go for this. Stop presenting. Okay, that's about it.
Okay,
I
thank
take
you.
longer time, I guess.
It's okay. So thank you very much, Prof. Ishak, for such an enlightening talk. Our next speaker up will be Technologies Bakri Alias. He's the Senior General Manager of Malaysia Automotive, Robotics and IoT Institute, or we simply call it MARI. This is just basically a Malaysian government agency under the purview of the Ministry of International Trade and Industry Malaysia, or MITI. He has been involved in the automotive industry since the year 2000, and his time in MARI would further expand his knowledge on policies of the automotive industry. So basically, the topics that Mr. Bakri will be sharing with us mostly on the perspective of government aspiration in electric vehicle or EV. He'll be talking about government policies on EV, especially the National Automotive, the NAP 2020, and feasibility of EV in Malaysia. Okay, so without further ado, I would pass the mic over to Technologies Bakri Alias, please.
Okay, thank you, Prof. I think we have echo here. I think probably Professor need to mute your speaker.
Yeah, it's much better now.
Prof, I think we still got a small echo. Professor, can you?
Yes.
Hello. Is it okay now?
Much better.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon. So my name is Bakri. I'm from MARI. So thank you very much for the organizer, which led by Mr. Lim Ki Yang, and also Prof. Lufti as the coordinator. So let me begin with the National Automotive Policy. So we go straight on the agenda. Next, please. Okay, this is the outline of this NAP 2020. So these are the subject that I would like to present. Next. So let me start with the background of NAP. So this NAP, National Automotive Policy, was started back in year 2006, where this is where we think that, that the government thinks that we need to have the dedicated policy with regards to our automotive sectors in Malaysia. So and then in year 2009, the first revision that we did on the NAP, which is focusing on the investment and also promotion. This is where Proton and Produa involving much on these activities. And then later in 2014, we are focused on this green and also sustainability, where this is where comes the EEV. EEV is the energy efficient vehicle. And last but not least, in year 2020, that we think that the government is required to follow the market trend and also the technology that might be available in the future. So this NAP 2020 was established with regards from year 2020 to 2030. This is more towards the enabling the existing EEV system together with the industrial transformation. Okay, next. Okay, what's the achievement of this 2014? So there are few. So I will only listed few achievement that government achieved on this NAP 2014. So in terms of GDP contribution, we recorded at 48.6 billion. So the numbers of employment in industry automotive from 2014 to 2018 is recorded at 244,000 employment in automotive industry. And then as well as the TIV, total industry volume, recorded in 2018 was almost 600,000 units. So from there, we think that this is the best way forward that we need to embark together with regards to Industry 4.0. Next, please. So the National Automotive Vision, the government foresee that we need to have a vision whenever with regard to this automotive, since automotive is one of the sectors that are providing higher GDNK to Malaysia. So government has listed five categories, namely supply chain integrations. So we are focusing also on the local manufacturing, engineering capabilities with regards to the latest technology trend, and last but not least, to develop the sustainability of this ecosystem. Okay, next. So with regards to the Malaysian vehicles projects, so government had decided to continue the support for Protons, Pro2, and also Modernus. So with that statement, so we had identified 6 criteria that we need to focus on. Number one is to make sure that the local majority of ownership of the national OEM, the private sector driven. We are also focusing on the domestic supply chains development, which is 75% local and 35% of foreign vendor. And also increase in the level of R&D with regards to the components and also finally we'll be focusing on the platform. And currently, due to pandemic, that government foresee that we are shortage of manpower. So that's why we are focusing on the local talents development, which is targeted at 98%. And last but not least, to develop this NXGV, which is next gen vehicle, and with regards to the Industry 4.0 introduction. Next. So these are the framework of NAP 2020. Actually, it's a combination of NAP 2014 together with a few elements that related to the connectivity, namely the next generation vehicle, Industry 4.0, and MAAS, Mobility as a Service. So under this framework, MARI had developed 7 national roadmaps and also national blueprint as stated below. Next. So government also had identified 5 objectives with regards to the NAP 2020. So as I mentioned earlier, to develop this next GV technology is number 1. Number 2, to expand the automotive sector participation in MAS sector. 3, to ensure the local automotive industry is ready with the embarkation of Industry 4. Second last is to ensure the whole system is benefiting and also the spin-off activity of this next gen vehicle implementation. And last but not least is to reduce the carbon emission by 2020. Next. So what are the elements inside this 2020? As I mentioned earlier by Prof, so we will focusing on the autonomous vehicle, but there are a level of autonomous vehicle in the world. So as for Malaysia, we are focusing up to level 3, which is a combination of human and also vehicle connectivity. So meaning half task will be done by human and half task will be done by the vehicles. Okay, next. So under this next gen vehicles, we will develop the standard, because whenever we discuss about autonomous, people will say, what are the standard? Is Malaysia having a standard? So MARI is given the task to develop a standard with regard to the AACV, autonomous, automated and connected vehicles. And also we will develop our EVIC, the Electric Vehicle Interoperability Center, which where all the components we need to do the testing, the validation, and last but not least, the energy efficient vehicle EEV together with the NXGV, the specification. Because previously we are focusing on the passenger car, but now we need to focus also the commercial vehicle as well as the motorcycle. Next. Okay, this is mobility as a service. as I think in Malaysia is already famous now, where the sharing concept like Grab, the Soka. So these are the sharing concept, meaning not everyone will be having a vehicle, but we can go from one place to another using the vehicles. And also the focusing on also multimodal transportation. Also e-payment. E-payment is where currently we have a lot of electronic payments in the system. So that's why we need to include this methodology into the vehicles. Telematics, where we can track the vehicles and also the performance of the vehicle. And last but not least is the connected living, where finally the EV vehicle will be power up the house in terms of the electricity. Next, please. Okay, with regard to Industry 4.0, so to comply with next gen vehicle and also MAAS, we had identified a few technologies that we required, namely the biotechnology, nanotechnology, quantum computing, and also governance. So under this Industry 4.0, which the policy was launched by former Prime Minister in 2018. So Malaysia had listed 11 pillars under this technology, which this industry will be, will be supporting the development of next GX and also MAS. Next, please. Okay, the direction of the Industry 4. So as I mentioned earlier, so this NAP was developed with a combination of the 2014 NAP together with the new elements inside the NAP 20, which is next gen vehicle, mobility as a service, as well as the implementation of the Industry 4. So this is where to ensure that the automotive industry is moving towards the connected mobility ecosystem. Next. So the direction number 2 is with regard to investment. So the government targeted to get the FDI amounting 3.64 billion for the next 10 years. The total investment in automotive sector recorded 10.05 billion in 2014 to 2018, and also domestic direct investment DDI of 6.41 billion. So so as this current and also new strategy will be implemented in order to increase the investment value to achieve the NAP 2020 objective. Next. So the direction number 3 is the market expansion. So definitely the Malaysian market is quite saturated. So we need, the government is thinking to export the parts and also component. So as I believe Malaysia is having a great capability in producing the components, the automotive component in terms of plastic parts, metal part, as well as the electronic component. So we need to, government also focusing on maximizing the use of free trade agreement, where when we have this free trade agreement, there is no tax being imposed into countries. And also last but not least, to encourage the utilization of the e-commerce platform. So this is this platform where we can sell the components through online. Next, please. Okay, the strategy. What are the strategies? So the strategy number 1 is definitely we need to support the value chain development. So we had identified 6 measures that we need to take in order to overcome the challenges of producing high supply chain component with the use of Industry 4.0 technology. With the pandemic crisis, currently we're having this Industry 4 is helping us a lot in order for us to increase our production capacity as well as increase the technology driven in the automotive sectors. Next. So the strategy number 2, human capital. Oh, so this human capital now is getting worse because of there is no foreign worker allowed by the government. So we need to fully utilize the local talents in order for us to ensure that our workforce is applying the new skill and also the knowledge elements. Next. And strategy number 3, safety, environment, and consumerism. This is to promote vehicle safety, application of environment, and introduce the consumerism element. So as I briefed by Prof just now, UPM and MARI, we are having a lot of collaboration with regard to this component development and as well as the platform. Okay, next. Under strategy number three as well, we are focusing on the environment. So currently, government now Malaysia are using the palm oil-based biodiesel. So we are at B10 now. So by 2020, or I think by the latest will be end of 2021, the government will be introducing this B20, and B30 will be introduced in year 2025. This is to support our oil palm industry. Next, please. Okay, these are the target of NAP 2020. I'm not planning to read everything, but the most of the important is the GDP contribution by the manufacturing, which is we target by year 2030 there will be 104 billions of GDP contribute to Malaysia. And the second most important thing is that we need to start exporting our CBU vehicles. So this is how we can survive in the near future. Next. So as I mentioned earlier, for the employment opportunities for the manufacturing, so we are targeting to create another 128,000 of jobs within 2020 to 2030 in order for give the opportunity for Malaysian to involve in this manufacturing sectors. Next, please. And the most important, I think, is the supplier development. So currently, we have a few categories of suppliers. We have currently about 600 suppliers all over Malaysia with regard to this automotive. But the tier 1 suppliers is only 400 suppliers. So that's why we need to increase the numbers of suppliers, where these suppliers are having a great chance to supply their products for export. Yeah. And last but not least, the technology development. This is where I think the government is seriously looking into giving grants and also giving the loans for the industries as well as the universities to develop the local technology. Next, okay, as a conclusion, with regard to Industry 4.0 NAP 2020, so this we have four targets. So number 1 is to formulate and continue to develop of local automotive industry. Number 2 is to ensure the realization of national automotive vision. Number 3, introduction of new element industry with regard to Industry 4. And last but not least, to create the new opportunities, not only focusing on the automotive, but other sectors as well. Okay, thank you very much for listening.
All right, thank you very much, Technologist Bakri Alias, for such an insightful talk, particularly on the NAP 2020, quite comprehensive, I would say, an overview of it. So our final speaker is Engineer Lee Yuan Hao. So Engineer Lee Yuan Hao is a founder and director of EV Connection Sendirian Berhad with over more than 10 years of experience in the field of electric vehicle charging infrastructure and solar PV systems. He is also Green Building Index GBI facilitator, Leadership in Energy and Environmental Design, LEED, and accredited professional in operation and maintenance, ONM. Basically, Engineer Lee will be covering on topics particularly revolving around the industrial practice, things like making and maintenance operation of a EV from an industrial standpoint. And next is quite interesting, especially for graduates, expectations on job applicants or applications in EV field. So with that, over to you, Engineer Lee, Yuan Hao.
Okay, thank you very much, Prof. Rufti, and good afternoon and Salam Ramadan. I would like to thank Mr. Lim also for organizing it, and also our fellow speakers, Prof. Ishak and also T.S. Bakri. So I will take you on the industrial perspective on the EV charging infrastructure in Malaysia. So myself is an electrical engineer. I will just go through a brief introduction on the classification on vehicles. Maybe Mr. Lim, you can go. What is the difference? I think this was highlighted by Prof. Ishak earlier, but I will just go through briefly. We have 4 types of classification on vehicle classification. One of it is the ICE, or what we call the internal combustion engine. We also have the HEV, or the hybrid electric vehicle. The one that we are more interested are the plug-in hybrid electric vehicle and the battery electric vehicle. Those 2 classifications are the one that we will require a charging station to actually charge your car. There are currently 4 types of charging modes which are available to charge your car. The mode 1 and mode 2 are basically portable charger where you use a 13 amp socket at your household to actually charge your car. The difference between the mode 1 and the mode 2, the mode 2 comes with a control box where they have the control and protection devices built in to actually use it to charge the car. So for car charging, mode 2 is allowed, but mode 1 is not allowed. For mode 3, basically you can actually see it in malls, shopping malls, in household, or also in hotels where they actually install an AC charger on the wall where you can actually see it from there. Mode 4 are those that we actually install it in highways where you actually need very fast charging, basically about 15 to 20 minutes to actually charge your car up to 80% before you move to the next destination. So what are the AC plugs? Of course, T.S. Bakri earlier mentioned that they have actually a center to have interoperability to have the harmonization on this. For AC plugs, basically we have 2 types. One of it is the type 1. Basically, we use it for Japanese cars. Cars like Nissan Leaf, Mitsubishi, they uses the type 1. Type 2 are more common where we actually find it nearly the OEMs, they actually use type 2 as part of their AC socket to actually charge their car. For DC plugs, we have 3 types. The first type is the CHAdeMO type, which is actually where the Japanese cars normally uses the CHAdeMO DC charger. The EU or the IEC standard supports the CCS2 combo. So this is the standards that are mainly used for DC plugs. But in China, it is actually one of the biggest market for EV. They have their own standard called the GBT. So, but cars that are exported outside of China, they will actually either put it in CCS2 or the CHAdeMO if they're exporting it to Japan. Normally, a lot of times people ask me, what is the difference between the AC charging and the DC charging? The AC charging, when using mode 2 or mode 3, you will actually have an AC supply to your car. Your car has a built-in onboard charger. The onboard charger is actually used to convert the AC to DC. So it's basically a rectifier before going into the battery. The power that you can actually supply and charge the car through an AC charger is very dependent on your onboard charger, or we call it OBC. For DC charger, why you can actually charge it very fast? The rectifier is actually built into a DC charger where the supply is an AC supply. It converts at the charger to become a DC before going in straight to the battery in the car. That is why for DC charging, you can actually pump 50 to some 175 kilowatt hour of power into the car very fast at one time. For those that have not seen the types of how does EV looks like, on the left side is actually a Nissan Leaf. You can see from there that they actually have two ports. The port on the left is actually a CHAdeMO port for you to actually put your DC charger. The one on the right is a Type 1 where they use it to charge AC. The car on the right is actually a Volvo XC90. They have only one port because plug-in hybrid has smaller battery capacity. They can only use an AC charger to charge it, and their socket is actually a Type 2. Next, please. This is also a sample of how does an AC charger looks like. It is actually mainly for malls where you have time to actually charge a few hours. You can actually install an AC charger. Next, please. The one DC charger on the left side is what we call a 175 kilowatt DC charger installed in one of the OEM's showroom. They can actually charge up a car within 50 to 20 minutes fully, and the car can actually run about 300 to 400 kilometers. So we are talking about very high power kind of charging. If you put it into a context of a household, that charger 175 kilowatt hour takes up almost 300 amps three-phase to actually power up that charger. If your household is 63 amp three-phase supply, you will need 5 power supply from the household to power that one unit of DC charger. So that is the kind of infrastructure and the grid support that we need to install DC charger. On the right side, it's actually a 50 kilowatt DC charger, consists of 2 types of DC plugs. The plug on the connector number 2 is actually a CHAdeMO plug. Connector number 3 is an CCS2 combo, and connector number 1 is a Type 2 AC plug. So it has actually we usually call it a universal plug where we can actually serve for different types of cars and users. So that's the summary table on AC charger. Where do you install AC and DC chargers? AC chargers are normally installed in offices, in household. Why do we install that in offices and household? Because you have time to actually charge your car. It takes about maybe 4 to 10 hours or 4 to 6 hours to fully charge your car. By the time you reach home or you park in your office, you have actually time to actually charge your car. Therefore, you do not need to have very fast charging. For the DC charger that you can see on the right side in the commercial and highway, if you require to have this kind of fast charging, definitely you need to put DC charger. AC charger, if you are traveling out of town, it is not practical for you to actually wait at the R&R for 2 to 3 hours just to replenish your car. That is why for highways and places where you need a top-up, DC charger is always preferred. What we do as an EV charging infrastructure service provider. These are a bit, because one of the things that I was told that what are the things that we can actually expect graduates, or what are the things that the graduates can actually expect if they were to come into this industry. One of it is the electrical home check and assessment. This is actually very important as part of the assessment for OEMs. Why is it important? It's to buy a car, you will need to have charging at home. Charging is always done at home 80% of the time. Only 20% it is actually done out of home or in the malls. That is why your home has to be assessed or do a home check to make sure that it has sufficient capacity and it is power to actually charge your car. Some of the cars now takes up to 22 kilowatt of power, which is equivalent to 50% of your household. The second, of course, is also very important, where existing high-rise building doesn't have a place to charge their car. Before we can actually install a charger or a EV charger at condominiums, we will need to do energy logging to actually know what kind of excess capacity which are available at your condominiums or your common area. Then after that, only we can design and retrofit the condominiums or the existing parkings to be EV ready. That is also part of the scope that for young graduates that is interested to be part of this EV facility installation and service provider company. The third it's the supply and install of EV charger. We actually have the international standards and also Malaysia standards. Those who wants to install, please go through the MS standard and also the international standard to make sure that the installation is safe and complies with the requirement. For testing and commissioning of EV charger, we also have the equipments and tools to actually do testing and commissioning. Because chargers installed, we have to make sure that the RCD works, where you can actually create a fault to actually test it. The loop impedance is actually low. The grounding is suitable for you to charge, because if the grounding is not good, charging certain cars might be a bit problematic. You might only be able to charge certain cars which are not sensitive. Certain cars might not be able to charge. Fifth, of course, you will need to come up with proposals and presentations of EV charger. How are you going to design and propose an EV charger for certain locations? Because maybe you have limitation on the power, limitation on the area, or limitation on the cable routing. That are some of the things that you will need to take care before you can actually propose a suitable solution for your clients. On the 6th, we will also usually come out or try to install a solar PV system as part of the charging infrastructure facility. Part of it is, as an electrical engineer, you all know that our power plant are mainly derives from fossil fuel power. And to actually drive a car, EV car is actually zero emission. But the source of power, we also have to green it to make sure that the whole ecosystem is actually green while driving an EV car. 7 is also something that the new engineers or the new graduates can actually think of: software and app development and the maintenance of the backend system, especially the platform. We have shortage of this kind of people currently in the market. There are not many software and app developers which are well versed with some of the languages and the systems that we are actually operating using our platform. So what are the other projects that we are working on which we think that there will be a future in it is energy storage system. As I mentioned earlier, currently we are working on a few charging projects where we need to put up a DC charger which takes up 300 amps of supply. The grid might not be able to support you 300 amps. What you're going to do? That is why you need to supplement the charging infrastructure with an energy storage system so that you do not overburden the grid. That is a part of the project that we are trying to implement. The second is the second life batteries of the EV. EV batteries, after 5 to 7 years or 8 years, it will definitely degrade either to 20 or 30%. That is the fact of batteries. You cannot have a batteries to maintain it to what? But what you can do with the batteries, if you were to replace the lithium-ion battery now from the OEMs, they are not paying you a single cent to replace the battery. If for you, lead acid, if you were to return it to a person, they at least give you a 10 ringgit or 15 ringgit to replace a 12-volt battery. Second life batteries, lithium-ion batteries has much potential. That is why we are working on a project where we are utilizing the old EV batteries as a storage system for us to store energy as part of the second life project. Third is the vehicle to grid. Vehicle to grid, currently it's only working on CHAdeMO plugs like Nissan Leaf. We have a vehicle to grid device where we will actually do a testing to help to supplement the grid if there is a shortage in terms of the thing. That is why it will tie hand in hand with the energy management system and the vehicle to grid. The fourth is the plug and charge that we are currently rolling out as a pilot project. What is this plug and charge? In a way, when you go to a charging station, you will need to either flash a card to tap on to the charging station, or you will need to use an app to start and stop the charging. If you have a plug and charge kind of feature, once you reach to a charging station, directly you plug the charger to the car. The charger can read the vehicle identification of the car and tell that this car belongs to Prof Ishak. It will automatically bill to Prof Ishak's account without you needing to open up the app or without you needing to operate using an app. The app is just for you to monitor your charging session and the charging usage and the kilowatt hour that you use. So these are the things that are very in advance. In other countries, it's also still very new. That is why we see that these projects will be very important as part of the EV setup and the infrastructure that we need. Next, please. So in a way, what are the competency and certification that we need as a charging station, charging infrastructure company? We will need wiremans. We employ all PW wiremen certified by Suruhanjaya Tenaga to actually do the installation, to actually operate and to do any access to the switchboard and to the main switchboard. You will need chargemen like A1, A4 for low voltage. That is also part of the things that the graduates can actually look at. Things like registered electrical energy manager, where you require to do energy logging and also to do energy study. It's also one of the things that you can also explore and the graduates can explore to do it. Paul, of course, is as an engineer, we are all talking about electrical circuits and design and single line and endorsement. That is also a path for us as engineers to actually achieve. Of course, the TUE certified EV installer, we can also be part of it, where you can actually get yourself certified and become an EV installer. 6 is SEDA qualified person if you are all going into the solar and photovoltaic industry, where you will need to have a SEDA QP to endorse and to do submission to SEDA. 7 is where we think there's a shortage of talents. We commonly now, we always face shortage hiring Ruby on Rails developers, Node.js, and people who are familiar with AWS, Amazon AWS, where we actually host our platform in our cloud. These are the people that are very well sought after in this industry currently. Next, please. So besides that, this is one of the projects that we did in Caltex. You can actually see it's actually partially powered by solar photovoltaic on a 50 kilowatt DC charger. Thank you very much from my side.
Dr. Lufti, I think you're muted.
All right, sorry about that. Again, thank you very much, Engineer Lee, for such an interesting sharing of the practice in industry, and you concluded it with the opportunities for graduates. That's really interesting because we are all from universities, so it's really good for us to actually relay the message to the graduates. Okay, so now it comes to our next basically session on Q&A, question and answer. So as I've mentioned, question and answer will be via direct questioning to the speakers. You can just cite who the speaker that you want to pose the question to, or you can also question through the chat box, the chat field that is available in this Zoom platform. So now I open the session for question and answer. Anybody, you can just raise and then ask question. We have a hand raised by Mr. Thomas. Go ahead.
Hi, good afternoon, everybody, and thank you firstly to all the speakers for sharing with us on some enlightening topics. I have 2 questions, and it's not to any particular speaker. It's open to all. Anybody can share their views. Number 1, the first question is, we know of late, our neighbors in ASEAN, particularly Singapore, Indonesia, and Thailand, have gone ahead in their plans for EV. So I'd like to know, in your opinion, how far behind is Malaysia in catching up with them? Number second question is, locally within the domestic auto industry, we hear often that the local policy for EV is still not very clear. The rules of engagement are not really made known or made clear to the players in the industry. So the question is, how far are we from getting a very clear and concise EV policy for our local consumption? Thank you.
Perhaps I can answer to Mr. Jacobs. Okay, with regard to the comparison between the neighboring countries on the incentive. So actually, previous plan, actually, I want to talk about the incentive, but the thing is, because this matter has been discussed seriously within the Ministry of MITI, the Ministry of Finance and other relevant agencies. So definitely, government is planning to announce soon, very soon, the incentive and also the support for this EV initiative in Malaysia. So I cannot disclose here, but probably next session, if we do have a next session, then it's a good time for us to share. But I can guarantee you that there are a lot of discussions being discussed with the on the top level. Okay, thank you.
Okay, thank you very much, Technologies Bakri and question coming from Mr. Jacob. We have some questions here posted over the chat box here. One is coming from, I suppose, is Dr. Engineer Fendi Yaakob. Very interesting session, thanks. My question for a common car charging station, maybe in other developed countries, how does they size the solar PV panels? How, the charging station, how do we, in that sense, deal with that with our own solar PV panels, I suppose? That is probably the question. Maybe Engineer Lee can answer, because I saw your PV panels picture
for us, how do we size this? Malaysia has a standard where the maximum that you can size for a low voltage system is 60% of your incoming current capacity. So if it's 100 amps, roughly you can size about 40 to 50 kilowatt peak kind of system, which the maximum that you can actually put. But of course, you also have to take note how much power that you are currently consuming, because sizing a very big system without your utilization, it's also doesn't gel. So that is why you will need to compare between the usage and the requirement of the authority to actually size your system in Malaysia.
Right. Thank you, Engineer Lee. I hope that answers the question. Okay, there's another question coming from Muzaidi Osman. Is there any benefits given by the government, such as road tax reduction, insurance, and so on for the EV owner? I suppose it's Technologies Bakri probably is the appropriate one to answer.
So currently, as I mentioned earlier, there are the discussion being going on with regards to the incentive to be given to the not only for the consumer, this incentive also to encourage the OEMs with regards to the manufacturing the EV in Malaysia, as well as for the vendors to produce the components of EV in Malaysia as well. So the incentive actually is not only for we are looking into the various aspects of the industry players. So we are looking into the OEM, we are also looking into the suppliers, we are also focusing on the consumer. Previously, yes, we do have some incentive, but that incentive is not that attractive compared to the neighboring countries.
Okay. Is there all? Okay. Okay, thank you. We have another question from Ms. KD Chong for Encik Bakri. Other than a setting standard, does MARI currently involved in providing industry support, such as providing endorsement to local industry players for penetrating into EV-related part supply?
Okay, that was the good questions. So MARI, instead of setting up the policies, we are also executing the technology development. During my presentation, I think I believe a few slides from Prof. Ishak. So since 2017, we had collaborated with UPM with regards to development of electric bus, as well as the wireless charging. And latest program is with regards to the electrics light commercial vehicle, also together with UPM. On the back to question on the activities that we're supporting to the industry is that we are now developing with industry players with regards to the development of component. For instance, the ADAS technology, Advanced Driving Assist System, together with the first-tier vendors in Malaysia. And we are also having the collaboration with potential universities with regards to the development of lithium-ion battery, as well as the Malaysian driving cycle methodology with regards to the EV. Yeah, that's all.
Okay. All right. Thank you, Technologist Bakri. Okay, we have another question from Ahmad Firdaus Ahmad Zaidi. May I know whether there is a specific grant for or funding related to prototype component development for EV, such as a powertrain system? Who can answer it? I suppose either Technologist Bakri or Prof. Ishak maybe.
Okay, so normally in Malaysia, when we have, for example, a powertrain system, so normally we from university, we make a proposal to the ministry. For example, Ministry of Education, Ministry of Science, and also MITI. Yeah, so it's based on what type of your current research. If let's say fundamental, then maybe perhaps the best place is to get it from Ministry of Education. Yeah, so then if let's say you have a prototype, you want to scale up, then maybe you can look into Ministry of Science. Yeah, then for commercialization, perhaps then can look into MITI. So there are various and also for training the what I call it the specific staff for EV industry, then maybe we can look into Ministry of Human Resource, like Mr. Lee. So maybe because I would like to raise the issue as well, because technical staff who can man the EV and also the facility, especially after the sales, that is also in great demand actually. Yeah, because when we have the technology, we don't have enough qualified people, and then we got some problem. So there, this what I call it, I think Mario also, I used to attend the meeting. Then I said they are in great demand as well. So it's another opportunity lah.
Okay, thank you, Professor, for the answer. And we have another question from Zishan Memon. Okay, is there any real-time demand-side management system in Malaysia? How can a consumer be convinced for sharing the battery energy to grid? Any convincing price benefits for EV consumers when supplying power to grid? So, who can answer this question?
Okay, I can. Yeah. For example, like for like solar panel, we have like a special incentive. Let's say if you generate electricity, especially for renewable energy source, then you can sell it to the national grid. Yeah, so we have some thing. For the EV, maybe not yet, because you need to have in terms of, because you cannot simply pump in the energy into the system, because you need to take care of the harmonic that you also injected into the system, into the grid. Because that need to be looked at, because in the EV it has all the converters, and these converters is also source of harmonics. So when you pump into the grid, you need to fulfill certain criteria before, otherwise you will pollute the what I call it the energy in the smart in the grid. So there's another things, and I've not heard anything on the from the vehicle to the grid yet. I know the idea. Last time we were thinking of doing that, but at this moment in Malaysia, that thing is not what I call it happening yet. Yeah, but the idea was there a long time ago. Okay.
All right, thank you very much, Professor. Do you have any more questions? Going once, twice? No more? Okay. So I think that would wrap up the webinar sessions. So finally, we have reached to the end of the program. What really an enlightening and insightful webinar this really has been. So we have learned a lot, right, on the way forward in electric vehicles, particularly in Malaysian perspective. So we are really so much thankful to the distinguished speakers, Professor Engineer Lee and Technologist Bakri. And of course, to all the audiences for taking your time off, right, for being with us in this interesting webinar on electric vehicles. But it's a little request before we call it a day, we would really like to have a photo session. So if you don't mind, just switch on your camera so that our program director can have photos of all those involved in this webinar. Okay, just switch on all the cameras, and then Mr. Kiang, you can, I think, now take over on taking the snapshots.
All right, sure. All right, so I'll be taking the picture now. 3, 2, 1. Another one. 3, 2, 1. All right, thank you.
All right, thank you, Mr. Kiang. So, Alhamdulillah, we are at the end of this program. Inshallah, till we meet again, inshallah, next time around. Okay, thank you very much. Aqulu qawli hadha astaghfirullahalazim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. And good day. Thank you.